When you unpack VAXMIDI, be sure to have plenty of workspace. There are a lot of components. A component list is included in the box. This long strip of plastic is one of the last components to go into VAXMIDI. Be careful not to throw it away with the packaging. It's an important piece. Inside the first box you'll find several circuit boards. The long skinny ones are the sensor boards that read the hammers. There's some felts, some ultra high density polyethylene strips, some key strips, it's also high density polyethylene, the elastomers, pitch bend wheel, mod wheel, some screws and nuts, and some packages of grease. At the bottom of the box are all the keys and hammers you'll need to build one 2-octave module. In the second box there's another set of components. Circuit boards, a bezel, a frame to hold the controls and pitch and mod wheel, a frame to hold the main circuit board, and all the plugs and jacks. Again, at the bottom are all the keys, and the packing list will give you an itemized list of everything that's in the box. Our first task is to test each circuit board and make sure that it's functional. This is the controls board. This is the main PCB. And the long skinny boards are the sensor boards that sit underneath the hammers. First, attach the main circuit board to the controls board. Notice that the red stripe is on the left side. We put these two boards into factory test mode by taking a MIDI cable and connecting MIDI in to MIDI out. You will do this several times during the assembly process. Get a standard USB cable and plug one end into a USB wall charger, the other end into the main circuit board. Factory test mode will be launched. If the boards are working properly, the display should look something like this. Now take each sensor board and attach it to the main circuit board with a card edge connector. The display should look something like this after a second or two. Repeat this for each of your sensor boards. Since circuit boards are sensitive to static, we're going to mount them to their mounting plates. First, take the control wheels, Mount them into the control plate. Mount the control board on top of the control plate using 6 standoffs. These are hardware parts with male threads on the bottom and female threads on top. Connect the control wheels to the control board. First, fold the small ribbon cable as shown. Slide it underneath the control board. Take the short end, fold it over, press it down to connect to the board. Take the other end, turn it 90 degrees and connect it to the control wheels. Mount the bezel over the control board using 6 screws. Attach a selector wheel to the post using a small screwdriver. Mount the main circuit board to its mounting plate as shown. Again, there are 6 screws. Connect the main board and the control board in the same manner as you did while testing those boards earlier. Since the lowest key on the keyboard is adjacent to the control module, we found that it's helpful to put some of the ultra-high density polyethylene tape on the control module's side. The key slides very smoothly against the tape. Several extra pieces are included with your kit, so cut off one and place it as shown over the right side of the control module. Trim the edges flush with a single edge razor blade. It's time to put the felts on the chassis. There's 2 different white felts included with the kit. One is a firm white felt and the other is a softer white felt. We're going to use a softer one to put on the chassis. The firmer one goes on the key base, as you'll see later. Take the softer felts and line them along the rails. You'll start at the far right side of the keyboard and finish 4 inches from the left side of the keyboard.
We recommend the Gorilla Super Glue Gel for bonding the keys. It's thicker, so it's a better gap filler, and it's super strong and works well in this application. So the only difference between this method and our previous method is where you hold the key and the key steel while you are joining the glued parts. Add a nice bead of it, and hold the very back of the key steel and put pressure down on the front of the key and slide it in as usual all the way to the plastic stop. That keeps the key straight and corrects any slight variation in the steel or the plastic.
The black keys do not require a fixture. You can just apply the glue, then slide the key steel in until the plastic comes in contact with the ridge running through the center of the key steel. Note that the white keys do not align to that ridge. The last step in building a key is putting the ultra high density polyethylene tape on the end of the key where it interfaces with the hammer. Once again, clean with alcohol. Peel off a piece of tape and place it on the end of the key bar so that it wraps around the rounded end of the key bar. Repeat this procedure for every key. Preparing the key base is a critical step. First, we're going to put ultra high density polyethylene tape on the bottom of the key base. This helps the key base slide in and out of the chassis. It also stops it from rattling. For the next step, you're going to need grease, a glove, and a finishing pad. There are 3 greases included in the kit. The heavy grease is the one we're going to be using first, the one with the green. Take the finishing pad and polish the loops. On the lower loop, just need to polish the top really well. 3 or 4 strokes with the finishing pad will do it. If you want to do 10 or 15, it's even better. Even more important is the top loop where the hammers run. The underside gets most of the wear, and that needs to be the smoothest. So take that finishing pad and make it as smooth as you possibly can. 10 or 15 strokes up there wouldn't hurt either. Take the heavy grease and using the glove, dab it on the underside of the upper loop where the hammer rides. Put it on pretty heavy. Dab it on like this. Now press hard and smooth it the best you can across the underside of the upper loop. If you get too much on, the hammers will smooth it out, so don't worry about that. The lower loop, where the keys ride, gets the light grease, the one with the pink label. Apply it to the top, dabbing it on just as before. and smooth it out. You can further spread it by running a key up and down the lower rail. Now we're going to take the firm foam and place it on the rail of the key base. This is where the keys rest. The elastomers provided in the system are machine cut, and being an elastic material, are not exactly the same length. This is an optional step, but if you would like to have exactly the same weight from key to key, take an X-Acto knife and cut the ends off of the elastomers to where they're perfectly the same length.
As you can see, this hammer has a complete slot, the aftertouch slot, and because of variations in the manufacturing process, there's flashing or excess plastic left in some of these hammers. Now you can remove this easily with just a sharp X-Acto knife and a flame. You just want to heat an X-Acto knife up and it cuts through that excess plastic easily. Don't try it without heating the blade because it's pretty tough plastic and you could wind up cutting yourself. So here's an example of how easily it can go through. And you can just do that a couple times and it clears it out.
A little detergent and some water makes the elastomers go on the hammers much easier. For every white key, you string an elastomer through the lower hole of the hammer and then attach it to the barb. For every black key, you string it through the upper hole and again attach it to the barb. Repeat this for both octaves of the key base. When you have 24 hammers, start attaching them to the two bankers. You start with the E on an F to E keyboard alignment. Then attach a black key hammer, the E flat. Then you'll attach a white key hammer, the D, and work your way chromatically down the octave. You'll build 2 sets of this for every 2-octave module. Slide the sensor board into the key base. Slide the two makers into the back of the key base and then start bringing the hammers on, aligning the first hammer with the 12th sensor and then bringing a key up underneath it. The hammers slide easily when there's no key underneath them, but once the key is there, the hammers actually intersect the sensor and they're held in place. So another hammer goes on and then another key goes underneath it. Hammer goes into the sensor slot. Notice how the sensors capture the hammer. Make sure that the wing of the hammer is in the middle of the sensors. If you don't, the note won't play. Repeat the operation for the other half of the key base with the other octave. Once the 2-octave module is loaded with keys, take your fingers and slide the sensor board back and forth. If there's a hammer that's outside the sensor, you can see that hammer wiggling back and forth. Press down on the front of the hammer and it usually pops right inside the sensor. Wiggle it back and forth, it should move freely, about 1/8 of an inch back and forth. Now it's time to test the module you just built. Slide it into the chassis. Get the main circuit board and the control circuit board and attach the main to the first sensor board. Slide the electronics in just far enough to where the keys are striking the felt. And now we're going to add power and our MIDI in to MIDI out cable to put it in factory test mode. And we're going to test each key to make sure it's registering. This is the most critical part of the entire assembly process. When you press a key, it needs to register a value higher than a couple of hundred. But if you're pressing lightly on the key, the lightest note you would possibly want to hit, and you see a number that is in the neighborhood of 38,000, something is wrong. A high number like that means that the hammer didn't make it completely through the sensor. Write down the names of any keys that have this problem, and we'll show you how to fix it in the next step. In this example, it was the low C that exhibited the problem. The way to fix it is pretty simple. You just take some alcohol, clean off the end of the tip, and add one additional piece of tape. This additional piece of tape has always fixed the problem. When you reinstall the key, the hammer will now give normal readings in factory test mode. Once all the key bases are built and tested, it's time to put the VAX together. This is the final assembly step. Placing a piece of cardboard beside VAXMIDI will make it easier to slide the key bases in. Slide the first one in and then bring in the second one and mate them using the card edge connectors. Slide the second one in and continue on with the third and fourth module on the longer keyboards. This is the key guide. It goes underneath the keys to keep them lined up, and we use the very light grease on the key guide. Put lots of grease on the sides of the posts. The key will ride up and down on these posts, and we want a very smooth action. Notice the bevel on one end of the key guide. The bevel goes on the left side as you slide the key guide into the chassis. You may have to raise up on the keys slightly to get the key guide to slide through. Keep inserting key guides one after another with the beveled side on the left until the key guides are all the way across the chassis on the far right side. Now attach the main circuit board to the sensor boards with the same card edge connector. It's easier without the cardboard with the main circuit board. Line the controls board up with its slots and push them in together. Doesn't hurt to do one last check to make sure the sensor board slides back and forth freely within that 1/8 of an inch span. Now attach the right end cap. You may want to just attach with a couple of screws. These two pieces make up the key riser. The key riser slides underneath the key guides, moving them up into the keys further. Remove the paper backing from the felt and stick it to the polyethylene slat, starting about 2 inches from the end. Now we bend up the polyethylene slat so that it can go underneath the key guides more easily. Slide the polyethylene slat underneath the key guides, holding the keys down on top of the key guides as you slide. This centers the keys and centers the key guides with each other. When you first start playing the keys will feel very sluggish. But after a period of time, up to 30 minutes if you used a lot of grease on the top rail, the keys will become very responsive. Now it's time to put on the right end cap. The final step is to attach the red nuts to the pedal inputs.
Okay, due to some variation in the heights of the key bases, the key guides may not go high enough into the key. And we have a fix for that. If that does happen, you can take some sharp cutters and just cut the top corner off of these stops. There are 4 per side. And this will allow the key guide to go further up into the key, and there won't be an issue. All right. And here, same thing on the other side. Just cut the 4 key tabs off at a diagonal so you wind up with just a nice, clean diagonal cut of the key stop, of the tab.
It didn't focus. We can get a close-up of that again.
Yeah. After sliding in all your key bases, you've already adjusted the sensor board so the hammer, the wing of the hammer is in the center of the sensor. Now sometimes after pushing this in, it might be off a little bit. Or move some. That's why we have this adjustment screw at the end on the right side. It's a nylon screw, and after you've screwed on the end cap, you can adjust this to just the right position for the sensor board and the hammers all the way across the board. It'll actually scoot all of the sensor boards across. And you can feel by just touching the keys when it's right, when you've cleared all the sensors. Okay. For those of you with an 8-octave board, we have included in your kit some rubber washers that you put on the screws between the end cap and the body for a better overall fit.
VAXMIDI is complete. If you would like to add the VAXMIDI decal, please watch the following segment.